Today we're talking about powers and exponents. A product of a repeated factor can be expressed as a power. For example, if you multiply 2 by itself 4 times, the proper way of writing that is 2 to the 4th power. This number is an exponent, while this number is the base. The base is the factor. That's the number that we're multiplying by itself. The exponent tells you how many times to do that. So, for example, 3 to the first power is 3. 3 to the second power is 3 squared, or 3 times 3. 3 to the third power, or 3 cubed, is 3 times itself 3 times, and so on and so forth. So if you write 3 to the nth power, that means 3 times itself n amount of factors. So let's write each expression using exponents. For example, if I have 1, 2, 3 negative 2's, I have negative 2 cubed, or to the third power. If I have 1, 2, 3, 4 3's, I have 3 to the 4th power. If I have an a and another a, I have a squared. And if I have a b, another b, and another b, I have b cubed. Go ahead and try these and see what you think. I'll be back in just a second to show you the answers. Okay, check it with your red pen. I have 3 4's, so I have 4 cubed, times 5 squared. I always like to keep them in number order, so from least to greatest. I always like to keep my letters in alphabetical order. Because m comes first, I'm going to put m cubed, because there are 3 of them, and n squared, because there are 2. So if they want us to evaluate the expression, then we are multiplying by the number of exponents. So I'm going to multiply this one 4 times. Remember, this is not 4 squared, or excuse me, 4 squared is not 4 times 2. It's 4 times itself 2 times. Just like the negative 2 is multiplied by itself 6 times. And the forgot that negative. And the 4 is multiplied by itself 4 times. Okay, so now we've got the repeated multiplication. Let's actually evaluate. 2 times 2 is 4, times 2 is 8, times 2 is 16. Now, a negative times a negative is a positive, times a negative is a negative, times a negative is a positive. So this is a positive 16. 3 times 3 is 9. 9 times 3 is 27, and times another 3 is 81. So we get 16 over 81. If I have negative 2 to the 6th power, this is 2 times 2 times 2 times 2 times 2 times 2, which gives you 64. And because there's an even amount of negatives, a negative times a negative, a negative times a negative, and a negative times a negative, it's a positive number. 4 cubed also gives you 64, and we don't have any negatives to worry about. Go ahead and try these, and I'll be back in just a second to show you the answers. Okay, grab your red pen. Here we go. So my repeated multiplication is shown, and my answer is shown. Make sure you check your work. Okay, so let's look at this one a little closer. How are these different? If I have a negative 4 squared versus a negative 4 squared versus a negative 4 squared. Okay, they all look like they have a negative, they all look like they have a 4, and they all look squared to me. But if we dig a little bit deeper, let's look at what this actually means. When we look at order of operations, we have to first square the number, which is 16. Then the negative comes out after that. This means take this first and then give its opposite. So a negative 4 squared is actually a negative 16. This is the exact same thing. The parentheses are just there, and it means the same thing as this one. So we square the 4, we get 16, and we bring out the negative. So these two are actually equivalent. This one is not equivalent though. What this one means is actually -4 times -4, and that is a positive 16. So the only time that the number is actually positive when it's a negative number being squared is when it's got that parentheses around it. This one right here is the only one that works like that. So now let's order them from least to greatest. Well, we've got -4 squared, which is equal to our negative and the 4 in parentheses squared, but those are both less than a -4 in parentheses squared. So these are our least and this is our greatest. You go ahead and try. I'll be back in just a second to show you the answers. All right, make sure that you've paused the video and you have a red pen to check your work. I'm going to show you what I did here. Okay, I'll show you what I did here. This is a -5 squared. It's in a parentheses, but the 2 is not outside the parentheses. So I'm still squaring the 5 first and bringing down the negative. Same thing here and same thing here. The only one that is an actual -5 and then is squared is this one right here. So these guys are equal and he is the greatest. All right, so patterns with powers. If we look at these ones are relatively easy for us. Notice that as I'm going down the line, I'm really just dividing by 2. Just like if I were going up the line this way, I would be multiplying by 2. So every number to the first power is itself. What does that mean about a 0? Well, if I continue this pattern and I divide 2 by 2, what is 2 divided by 2? The answer is 1. So we can conclude that every number to the power of 1 is itself, and any number to the power of 0 is 1. Let's double check that one more time. What if we use 3's? As we go, we're dividing by 3, so 3 divided by 3 is 1. Wow, now we've got negative powers or negative exponents. So if we continue this divide by 3 pattern, what's 1 divided by 3? 1/3. Awesome. What's 1/3 divided by 3? 1/9. What's 1/9 divided by 3? 1/27. If you look at this repeating pattern, anytime you have a negative exponent, it's same power but over 1. It's a fractional form. So any non-zero number to the 0 power is 1. Any non-zero number to the negative power is its inverse. So when we look at this, 7 to the -3rd is like having 1/7 multiplied 3 times, or 1/7 to the 3rd power. For example, if I write 6 to the -3rd power, it's like 1/6 to the 3rd power, which we know 6 times 6 times 6 is 216. So it's 1/216. If we have a to the -5th power, it's like 1/a to the 5th power. Try these. See what you can do. I'll be back in just a second to show you the answers. All right, grab your red pen. So take a look at my work. They want us to write them as positive exponents. So the only way to make these exponents positive is to put them all over 1. So what if they give us the fractional form and they want us to write it as a negative exponent other than -1? Well, if we know that 5 squared is over 1, then we know that it is 5 to the -2nd power. If we have 1/36, we can look at 36 as an exponent. What number times itself gives you 36? 6 does. So we could use maybe even 6 squared. So 1/6 squared could also be 6 to the -2nd, or 6 to the negative square. All right, try these. Write each fraction as an expression using a negative exponent other than -1. I'll be back in just a second to show you the answers. Okay, grab that red pen again. Okay, an 8 cubed over 1 is really 8 to the negative third power. 4 could be multiplied by, or 2 times 2, which would be 2 squared. So 1 over 2 squared is really 2 to the negative second power. 1 over c to the fifth power is really c to the negative fifth power. And 1 over 27 is really 3 to the negative third power. So, because 3 times 3 times 3 gives you 3 cubed. All right, that's all I have for you. See you next time.